reversible processes. This term you will study in the field of thermodynamics. If you are a student of mechanical engineering, then your subject, name of the subject is thermodynamics, and there you will study this topic, reversible process. So what is reversible process? How is it defined? A reversible process. A reversible process is a process in which both the system and the surrounding can be restored to their initial state without leaving any trace or relic either in the system or in the surrounding. Means, suppose a process has already occurred. A process has occurred, say from state 1 to state 2, following a path. The process has occurred. Now, what is the requirement? Requirement is that you have to go back to state 1 again by following the same path. From state 1 to state 2, the path followed was like this. Then again you have to move from 2 to 1 following the same path. So if you do this, in your system, the system goes back to the initial state from where the process was started. But is there any trace in the surrounding left by the process? Yes, always you will find that there is some trace or relic left in the surrounding. Though in the system there is no trace, you won't be able to find any trace or relic inside the system. But if there is any change in the surrounding, then the process is not reversible at all. So in a real world problem, means in practical problems, you won't ever get a reversible process. Still, this concept is used just to make the upper bounds, to know the upper bounds of any process. This concept is highly useful, and that's why this should be known by all the students of mechanical engineering. Again, this topic is not this topic does not belong only to mechanical engineering field. This is actually a subject of physics, and this is useful for many fields, for many practical applications, for many practical calculations. And if the process is not reversible, that means the process is irreversible or non-reversible. And in real world problems, all the problems are actually irreversible in nature. Yes, irreversibilities involved in different processes are different. In some process it may be very small, in some process it may be very high or very large. Okay. So again, if you study Clausius Statement, means second law of thermodynamics, there are two statements, you know that thing. So there is one statement called Clausius Statement, and according to Clausius Statement, from a colder to a hotter body, heat cannot flow of itself spontaneously. Means some work must be expended, and this was mentioned with respect to a reversible process. Okay, if you study Clausius Statement of the second law of thermodynamics, then there you will find the term reversible, means the phrase you will find there, reversible process. Means the statement is like this: in a reversible process, it is not possible to transfer heat from a colder to a hotter body spontaneously. That means some work must be expended to achieve this, such as a refrigerator, such as AC, means air conditioning. So anyway, this is actually, so what, in summary, I should say that a reversible process is a actually hypothetical process, or it is an idealized process. In reality, you won't find any such process. But this process is useful for the purpose of many calculations and many other things are involved. In many cases, actual processes are not known. To make the calculations, to simplify the calculations, sometimes we need to take the help of this concept, reversible process. If the process is reversible, calculation becomes easier. Calculations become easier if you assume that the process was reversible in nature, though in reality the process was not reversible at all. Anyway, this concept is highly useful in the study of thermodynamics. Okay, so you should study well about this. Causes of irreversibilities are what? Because in any process, friction must be there. Frictionless system is not possible. If there is finite temperature difference between any 2 points inside the system or between the system and the surroundings, if there is finite temperature difference, in that case also, the process cannot be reversible. Yes, quasi-static process, this is considered to be a reversible process. You know that quasi-static process means there are small changes between any two state or between any two stage, and all the small changes are almost static. Means it is actually an infinitely slow process, and since the process is very slow, so it is assumed that this is also hypothetical. Okay, it is assumed that changes are frictionless. All the states passed through during a process is reversible in nature. So these are just assumed. Okay, I think you might have studied this term, quasi-static process. It is actually infinitesimally slow process, and quasi-static processes are considered to be reversible. Okay, every state passed through during the change of state or during a process, these are considered to be in thermodynamic equilibrium. Means each and every point, if you take the curve of a process is represented by curve on PV diagram or TS diagram. TS means temperature entropy diagram, PV means pressure and volume diagram. Okay, pressure volume diagram. So continuous lines are used, and each continuous line consists of infinite number of points, and all the points are thermodynamically equilibrium points. Means all the points are at thermodynamic equilibrium. So these are only the concepts. Okay, in reality, these things don't happen. Anyway, so this was all about reversible processes. Thank you for watching this video.